everyone, and welcome back to CS 120 Bitcoin for Developers. This is our Unit 5 review. If you haven't been following along, this is a supplement to Saylor Academy's course. You can find a link to the course in the description below. Sorry, as well as a playlist of the previous videos we've done. We've done a review for the last 4 units, and I'm going to hand it over here to Hannah and get us started because we're running a couple minutes late. But if you guys have questions as we go through any of this, feel free to leave them in the chat below. Or if you're watching later, you could leave a comment. But I'll be back when I'm needed.
All right. Thank you very much, Mike, and welcome everyone. We are going through Unit 5 today, so we'll get right into it. The topics, because again, as Mike said, this is a supplement to the course. So the topics that were covered in Unit 5 of the course are how Bitcoin transmits data on the network, how Bitcoin addresses and keys, and hex encoding, and how Bitcoin stores data in the block structure. All right, so basically all about data, and that's what we're going to be talking about today. Data, and more data. So specifically different types of data formats, how to recognize them, how to convert between them, how to make use of them. And so, again, this course is, designed to help prep people to work with Bitcoin, right? So this is sort of to prepare you to encounter these different data formats and these different data types to help you to be able to recognize them, to know what you need to do with them, et cetera. Because as you're, working in this space, if you're, building an application that is talking to a Bitcoin node, and I've done a lot of that sort of type of work, that type of building, and you'll definitely come across situations where you're receiving some data, from a Bitcoin node, a wallet, an application of some sort, and you're like, and then you have to deal with that in some other system over here, right? So you're going to need to be able to look at that data, be like, is that base 64? Is that base 58? Is that hex? Is that PEM? Is that dir? Like, what type of data is this? So I can know, what libraries and what functions I need to use over here to handle this data and to communicate back and forth. So if you wind up building applications that talk to the Bitcoin blockchain, that talk to Bitcoin nodes, et cetera, this is very, very helpful information, right? If you're not aware of things like, Endianness and these different formats, you can definitely wind up scratching your head and trying to find people on forums and all sorts of different stuff to sort this out. So as we go through, I think it's important kind of to, with that in mind, like you don't need to necessarily, memorize some specific details about the ASN1, data standard and formats, right? It's, I think, prepping you to work with this stuff. So it's the goal is to help you recognize, like be aware of the different data formats that are out there, be able to recognize them. So then, when you run across something, then, you can go Google the specifics of what you need to know, find the right libraries and functions, et cetera, for managing that type of data. So that's sort of the goal here, is to prep you to recognize and start working with these different data formats and understand why they're used. Please do ask questions all throughout the session as we go, drop them in chat, and Mike will relay them to me as we pause periodically in the session to do a bit of Q&A. All right. So what data formats does Bitcoin use? So this is kind of what we'll discuss today. It's not meant to be completely comprehensive of everything that Bitcoin uses, but these are some major ones that we'll discuss today, right? So we're going to talk about base 58 and base 58 check encoding. We're going to talk about WIF or WIF or however you want to say it. It's wallet import format. PEM. We're going to talk about ASN1 briefly, and we'll talk about dir a little bit as well. And of course, talk about hex, and don't forget the Endianness, right? This is what we will go through today. We also have 3 possible exercises that we could walk through today. So I think we'll kind of go through some of this, see, we won't have time to get through all of them, I don't think. So we'll kind of go through this, see where the Q&A takes us, and maybe you all, whoever's on the live stream today, can tell me which one of these exercises we have that you'd like to do, but we'll get there in a minute. Okay, so we've talked about some of the different formats right here. We've noted some of these data formats that are very relevant to Bitcoin. And then we'll want to talk about why has Bitcoin chosen these particular formats, right? Why are these formats used? And so here are some themes. So as we go and talk about why we're using this, why we're using that, as we go through each one of these formats, a theme that's going to pop up a lot is compression, right? So space on the public blockchain is very scarce and valuable, right? So you want to be really, really mindful of what you actually put onto the blockchain. So in many, many cases here, these formats were chosen to compress data as much as possible so that we can be really mindful of what we're putting on the blockchain. Not just so, we can help our fellow Bitcoiners out and not bloat the blockchain, but because anything we put on there is potentially expensive to then use and work with, right? So space on the Bitcoin blockchain is a scarce and valuable and sometimes very expensive resource, right? Or it could potentially be. So you always want to keep that in mind. Compress the data as much as possible. Like you only want to put absolutely the data that you need onto the blockchain and nothing less, or sorry, nothing more than that. So only what you need. So as we go through these, we'll see that compression is a really common theme in these formats. You want to save on block space. Error prevention is another one, right? And especially when it comes to Bitcoin addresses, these aren't very, right? There's this sort of trying to walk this line between making something really compressed that a computer can read, but also making something that a human can work with without too much error, right? So trying to walk the line on some of those things. So we'll look at a bit of formats that are used to prevent errors. And then security, right? Obviously, we want to make sure that whatever we're using here is secure. So that's also a common theme and concern for why you choose certain formats. All right. So let's go ahead and get into the first of these. We'll tackle base 58, and then we'll stop and do questions after base 58, I think. Okay, so this is, you'll see this one a lot, right? And one of the things that I hope we'll all achieve by the end of this session is being able to just like look at some data and spot it and be like, that's base 64, that's base 58, that's hex, and just being able to spot those things will be pretty handy with you if you wind up working with Bitcoin data a lot, right? All right. So base 58 is a text-based binary encoding format, right? So it's a compact representation for readability and error detection and prevention, right? So it is, so base 58, so, we think of decimal, right? It's base 10, right? And then we'll talk about hex, which is, base 16. And base 58 uses 58 different characters, right? So each digit, right, that can be one of 58 different characters. And this is a subset of base 64, right? So base 64 is a data encoding format that's been in use for a while. We'll see it in some of the, private key formats. We're going to see some base 64 here today. So base 64 existed and was used, long before Bitcoin, right? But base 58 was created specifically for Bitcoin. And this again is, base 64 is a very good method for compression, right? So storing a lot of, storing data in a very dense way, right? So it's good for compact representation, but also because we care about making it, making sure humans can work with this. We want there to be readability and that error detection and prevention. So you started with base 64, right? And that is what base 64 is taking all the letters in the alphabet, both uppercase and lowercase, and then taking all of the numbers 0 through 9, and then it also has a couple of symbols in there, like a slash or a plus sign. And so then you take all of those characters, right, and that's where you get base 64. So Bitcoin took, base 64 and then made it more human readable, right? So it removes, base 58 removes characters that are frequently mistaken for one another. So you can see base 64 and base 68, it took out, what was that, 6 characters? So it removes things that are easily confused, such as in uppercase O and 0, right? Or L's and I's, things that can commonly be confused for each other. And then I believe it also took out those couple of symbols that were in base 64, right? So you're not going to see those, a slash or a plus sign or something in a Bitcoin address, right? So it does that to make it a lot more usable for humans. So I don't know if any of you have ever had, thankfully the UI on Bitcoin wallets is much, much better these days. But back in the day, you might have to like try and copy a Bitcoin address from, one thing to another, or, give someone your Bitcoin address over the phone. And it's, it can, uppercase A, the number 2, it can be very tedious and it's easy to mess those things up, which is why some of these characters were removed. Okay, so that's base 58, right? And that's just taking that base 64 and removing some of those characters so we have a bit more easy for humans to communicate with of base 58. But what's commonly used, what's the standard for Bitcoin addresses is to then not use base 58, but use base 58 check encoding, right? So here you can see on this graphic, this is taken out of the Mastering Bitcoin book. So you have this, payload, right? So this, let's say, is our Bitcoin address, right? In this base 58 format. Then you add a version prefix to it, and we'll talk about that again. So you should have some familiarity with the versions to help you read data as you're seeing it, and you work with these programs. So you add a version prefix to it. Then you take the version prefix with the payload and you hash it. So we basically do SHA-256 twice. Then you take the first 4 bytes of that hash and you stick it on the end of that payload, so you have a checksum. And the idea here, right, and then you take that all together and then you have, your address. That's your Bitcoin address. Now, the idea is let's say I have a Bitcoin address and I'm trying to say I'm trying to type it in to, a web wallet or something, right? So it's an exchange account that I have, right? And I'm trying to type in, I'm reading, this address off my phone and then trying to type it in to, an exchange account, right? To have that exchange account send me those funds, right? We want to try and prevent someone from just entering the wrong thing, right? Hitting, the wrong, just, hitting P instead of 0 on my keyboard as I type that in, right? Because, we're humans, we can do this sort of thing. So the idea is once I type that whole address in, whatever program is receiving that data is going to know to check and make sure this is valid. So it takes those last 4 bytes as the checksum. It takes the rest of it, right? And it's going to run it through this hash, this double hash, and check the first 4, first 4 bytes and check it against this checksum received off the address, which is those 4 bytes right at the end of that address, right? So it does this, and if it doesn't match up, then it will reject that as an invalid address. So it's a way to prevent funds from being lost just by me having a typo and hitting the wrong button on the keyboard as I input this information, right? So this, I have no doubt, has saved millions of dollars in lost funds, right? Because it's very, very easy when typing these addresses just to hit the wrong button. So this is how we prevent errors or help to prevent errors in Bitcoin addresses. So base 58 and base 58 check. And let's go briefly through the version prefix before we do questions. But if you've got any questions on that, please type them in the chat. Now is a good time. All right, so that version prefix that gets added to this stuff can help us to identify different types of addresses on the Bitcoin blockchain, right? And again, when you're working with this data, it's very handy for you to be able to look at that address and spot what's going on there, right? So the most common type is just to add this version prefix 0, right? And then when you run it through all this formatting, that means that Bitcoin address is going to start with a 1. And this is just a standard, pay to pub key hash, right? Then for, we won't go through all of these, but you can see this different version prefix, this 05 is added to a pay to script hash address, and that results in that address starting with the number 3, right? And so, you don't necessarily, if you're going to be working with this a lot, then it's probably a good idea to have some of these memorized so you know what they are. If it's the Bitcoin testnet, it's going to start with like M or N. We're going to talk a little bit about this private key format. That's going to start with 5, K or L. XPub, that one can be really handy. We're not going to talk about XPub keys now, but just being aware of what that is when you see that. It's extended public key. That can be really handy as well. Also, we'll take a moment to note here on the hex column, you see all those numbers there starts with 0x, which we'll see again later on, but that's just a way that like hex tells a computer that, hey, there's a big long number coming after this. So when you see that 0x, probably like a hex number. All right, we'll stop here before we dive into key formats. Mike, do we have any questions on just data encoding in general and base 58 or base 58 check?
Yes. Well, first of all, we had some hellos from around. We got a UK hello, a couple Illinois. It looks like.
Nice.
We
My
had.
state.
Oh, there you go. So we have a question here about about the 58. Sorry. Were the symbols for the base 48 chosen based on a specific font, or is there a recommended font?
This is a good question, right? So in some fonts, right, you might be able to tell the difference between like, an uppercase I and a lowercase L, and in other fonts, you cannot, right? So I don't know that there was like a specific font in mind, but definitely the idea was that in some fonts, telling the difference between uppercase I and a lowercase L is like, they're the same, right? So because there are some fonts where you can't tell the difference, those are removed. So I'm not sure, I couldn't name offhand what the offending fonts are that won't let you tell the difference between an uppercase I and a lowercase L, but they're certainly out there. And yes, they were the motivation for base 58. Yeah.
It's crazy to me they still make fonts where you can't tell the difference between an I and an L. But well, we're not seeing any more questions in the chat right now. But again, if you guys have any questions as we go along, please write them down in the chat below or next to you, however it works for your setup, and we'll get them out there. So Hannah, I'll hand it back to you.
All right, thank you. Okay, so we've covered base 58, why that exists. This is a very, very common one. We'll see it everywhere. Now we're going to talk briefly about key formats, right? And again, what's often happening with key formats is we are trying to preserve the data, right? It needs to be exact, right? It's very specific information. It needs to be exact, but we also want to condense it down as much as we possibly can. Okay, so here again, we don't want to get into things on the level of we need to know exactly how these different formats work, right? This wallet import format with, like, you can go dive into that if you want to, but the idea here is if you're working with this stuff, you're gonna run across these formats. And I would like you to be able to spot them and recognize them and know what to do with them. So first we have, again, this is pulled from the Mastering Bitcoin book and some of the chapters that we covered for Unit 5. And so we have different sort of formats that can be used for keys, right? For public and private keys for transmitting those when necessary or storing them, right? First one is just raw, right? Just binary, right? 32 bytes. We're not going to display that here because it's not really displayable. Second is hex, right? So we'll talk about hex in a minute. And then you could display a key in 64 hexadecimal digits, right? Then we're going to do this WIF, this wallet import format. And this is where a key is stored in base 58 check encoding. So again, you would have that little bit at the end here, this checksum that would be at the end of that. And that has a version prefix. So you can see that hex 80 and a 4-byte checksum, right? So again, important to know, right? Because you might be trying to get, one wallet to talk to another wallet, or make it such that the wallet you're working on can import keys from, another wallet or a node or something of that variety. And so you need to know, okay, this format is what we're going to use. I need to have, I need to find a library for the programming language that I'm using that can work with this particular format. I know that this is going to have a checksum on it. I'm going to have to write some code. If it, it doesn't exist already in this library I'm working with, then I'll need to write some code to make sure that I check that checksum, right? And so we don't need to go through exactly the details here. You just need to know what's out there and what they look like. So when time comes, you know what tools you need to work with them. All right, so we have two different types of formats for this with two different varieties of the WIF format. We won't get into the woods with that, but there's just a regular one and a compressed one. And standard starts with 5 and the compressed starts with K or L. So here we have some examples down here, and this can help us a lot in just getting used to looking at these things and seeing what they look like. We'll talk about hex in a minute, but when we go down here to the wallet import format, first of all, we can see it starts with the 5. So we can remember that's the uncompressed version. And down here, we can see that this one starts with a K, and we know that compressed is going to start with K or L, so that's the compressed version. So again, if you were working with this data, you would need a library, and if you're seeing this data come in as K, or you might get that data, then you're going to have some sort of library that can work with compressed, right? And we can see here, we just talked about base 64, base 58, and we can see what's going on here, right? We can see that we have letters, all different kinds of letters in the alphabet, letters from the beginning of the alphabet. Here's an A, letter from the end of the alphabet. Here's a W. We have uppercase, and there's a lowercase J and M. So we have uppercase and lowercase, and we have some numbers. So looking at that, we can, after a while, get used to it. You can look at that and go, aha, that's base 58, right? And so I can see that. I kind of know what I'm going to have to do with that. All right. Key compression. We're not going to get too in depth with this, but I just want to show you this to show you how much Bitcoin and all these formats we use try to compress data. The idea being that you only want to ever broadcast to the blockchain or put into a block absolutely just the bare minimum of data you need. So without getting too deep into the math, we can see that a public key is sort of comprised of like 2 different numbers. And what you can do here is, because if you have some bit of information about this, right, if it's even or odd, we won't get too in depth with it, but if you have some information about it, then you can derive the second number from the first number, right? So you kind of, in some situations, you only need to store like 1 part of this public key, right? So you really, you try to only store exactly the data that you need to. If we have just this information, we can recreate the whole thing. Therefore, we're going to store just this information and expect anyone working with this data to be aware of that and know that they're going to have to take this information and then run it through a program to recompile recreate the whole bit of the whole information, right? So very important to know that, Bitcoin is expecting you to know what to do with this data. It's only going to give you absolutely the bare minimum, and you need to know what that data is and then recreate the full thing because you'll have to use that in other parts of whatever program you're working on, right? Okay. Now let's look at this again. And here is just another example of how we can store private keys. Here's hex. We'll come back to hex in a minute and learn how to spot that. Here's this WIF format. Again, look at that. That starts with the 5. That's non-compressed, right? All right, here's some hex compressed. No, I won't touch that too much today. And then there's this WIF compressed, and we can tell that because, it starts with a K. It would be, was it a K or an L, right? So again, just getting familiar with being aware, getting familiar with what data formats are out there and getting comfortable with spotting them so we can know what to do when we see them. All right, Mike, do we have any questions on that before we dive into PEM? No? Or maybe you're on mute.
Sorry about that. That wasn't the setup anyone wanted. No questions coming in right now. We got a hello from North Central Pennsylvania. The geography is coming out today. Maybe they can see the little map. I didn't crop that.
Excellent. Well, hello, Pennsylvania. Yes.
But I'll let no question right now. Again, if anyone has any questions, feel free to leave in the chat, and I'll be back if we have some for you.
Okay, cool. We'll go through this next section. All right, now we talk about when we're working with keys, and if anyone's, a developer who's worked with public and private keys in other situations, you might be very familiar with this public key block here. Specifically, if maybe even you're just like SSHing into different servers, you would have to generate a key pair, and then perhaps you have to take
sorry,
the
Hannah.
public.
I meant to. We just got a question in real quick, and I figured before we get going, maybe we should.
Let's hear it.
We should hop back real quick. What do we have here? Do other cryptocurrencies have these complexities of encryption?
So this, yes. Encryption isn't really quite the right word here because we're not actually encrypting data. We're using we'd say more data formats, right? But yeah, I think most crypto, so any crypto that's sort of a fork of Bitcoin or based off Bitcoin is going to be using, base 58 and all this stuff. And there are far too many other ones out there for me to be aware of what they're using. But I would guess in the vast majority of cases, if you're familiar with these data formats, you're going to run across them in any other sort of cryptocurrency that you would be working with. So short answer there is yes. Yeah.
All right, awesome. Hopefully that answered your question, and I'll be back if we have any more.
All right. So here, and I have a question for you all in a second. Here, saying you may be familiar with this if you've ever done something like you had to set up some keys to be able to SSH into like an AWS, EC2 instance or something of that sort, right? You would have generated a key and you might have had to generate this on your machine, cat it out and then just like copy and paste over, to some AWS UI, right? A lot of you might have had that experience. So let's look at this key or this, public key as it's formatted here. And I'll have a question for you all. Who can tell me what format this is that we're looking at, right? So I did put the link here, but maybe don't cheat and go there just yet. Right, let's have a look. And we can see we have letters, right? So we have letters from, the English alphabet. Here we have uppercase, here we have lowercase. We also have some numbers, 9, that looks like a 0.
And we have a guess in the chat.
All right.
Base 64 from David Cooper.
Base 64 is the winner. So good job to whoever that was. Yep.
David
That's
Cooper.
Exactly.
There you go.
And we can tell this is base 64 too, because look at these symbols. See here, we got a slash and we have a plus, and we're not going to see that in base 58. Like you're not going to see slashes or pluses in a Bitcoin address. So here we go. This again, base 64 existed long before Bitcoin, and it's a format commonly used for keys. All right. So, but also we have to talk about PEM. And again, we're not going to get too into the woods with this. Just something to keep in mind. A lot of times, you'll have when you generate, key pair to SSH into some server, we'll say private.pem. Right? This is a specific way of encoding that data. It uses base 64, and this is what it looks like. So again, we want to be familiar with this. We won't, it's sort of outside the scope of this course to dive into the specifics of PEM, but something you want to be aware of. There is where you can go get more information. All right, so we're going to roll across to, this is another one, ASN 1. This is in old school format. And this also is something you want to be aware of, but outside the scope of this course for you to get super in depth with. Also when working with this stuff, you want to be aware of what it is so you're not surprised or confused when you see it, but probably don't need to know the details of it all, right? Maybe in some application you might wind up having to dig into it. All right, so this is a cross-platform standard for data transmission, right? If you would like to dig into this, or you ever, come across this one day and need to really dive down that rabbit hole, here's a good place to start. Originally defined in 1984, so this is, one of the originals, right? Okay, so that's all we're going to say about that. You might see this, should know what that is. It's, long-standing standard for data transmission. All right, and DIR. Let's roll right into DIR. This is Distinguished Encoding Rules, and it is part of the ASN1 standard. All right, and this is a binary format, right? So it's not human readable. This is binary. And this we use a lot because when you need to be really, really specific, like binary level specific with data, DIR is often used. So that means when you're generating and validating digital signatures, you need to be really, really specific, right? You don't want to get that wrong. You have to generate a signature properly so that someone else can validate it. And when you're validating it, you want to be really sure that that's either a valid signature or an invalid signature. So when you need to be really, really specific, this binary level specific encoding is often used. This will be what it looks like. Now, DIR is often shown to humans, right, in, I believe it's hex format, right? And again, won't get too in depth, but if you want to look at some DIR data, you can actually spot in it this tag length value format that it uses, right? So you can see here's an example of like some DIR encoded data. 02 is the tag for integer, 01 is the length of the value, and 02 is the value. So that's basically the DIR way just to communicate the number 2, right? Again, won't get too in depth with that, but when you actually look at DIR data, you can pull up all the different tags and you can kind of go through it and see where the tags are and what's going on. So that can be fun if you're like a big data nerd. Okay, hex. Let's get into what's happening with hex because this is everywhere, right? And if you've taken any computer science classes or any of that, I'm sure you've dealt with lots of this. Okay, so it uses 0 through 9 and the letters A through F. And sometimes you'll see this sort of in lowercase, sometimes you'll see it in uppercase, but it's not like, it's going to be like all lower or all upper, right? So it's just the 0 through 9 and A through F. All right, and it's a human-friendly way to represent binary values. So something like DIR, you're often going to see, in hex, so it's readable for humans. So each hexadecimal digit represents 4 bits, half a byte, which means that a single byte can have values ranging from, here it is, in binary 000 or 111, which can be much more compactly represented in hex as either values from 00 to FF, right? So you can see this is a more compact way to represent these values in a readable format or, and sort of you have to communicate it in text in some capacity. All right, so it's, as I was going to say, a human-friendly way to represent binary values. And we'll see hex everywhere. And we'll look at this again in a second and be able to sort of spot hex. All right, so now all of that being said, you might still be familiar with all of these different data formats. And let's imagine you have some Bitcoin node you're talking to, right? And then you have some application over here that you're busy building that's supposed to be taking data from the blockchain, right? And you might get some data and you look at it and, aha, I'm familiar with hex. I can see that there's the letters A through F and the numbers 0 through 9. So as I'm receiving this data, aha, I know I have to use some functions for working with hexadecimal data, right? So you go and you do the right functions and you run it through, but still it's like you're getting gibberish out the other end. Like something's just not right. What's going on? You can run into this, and this might be an issue of Endianness. Now I'll read this and we'll talk about it briefly. So a big endian system stores the most significant byte of a word at the smallest memory address and the least significant byte at the largest. A little endian system, in contrast, stores the least significant byte at the smallest address. So kind of think about this as like some languages are written left to right, and some languages you write them out right to left. And that's kind of what this is referring to. So it might be that you have the right data, and I'm kind of simplifying it a bit here, but just keep this in mind. If you ever run into an issue, where it's like, I think I have the right format, what's going on? Like, don't forget to check the Endianness, because that can definitely be an issue when dealing with data, blockchain data, and how this stuff is stored. Because remember, it's always going to be stored and transmitted in whatever is the most efficient fashion, and it's your job as a developer working with it to be aware of that, and then take that tiny bit of data and use that, and then you transform that data how you need to work with it, because it's only going to be given to you in the a lot of times, when you're working with the back end stuff, it's going to be given to you in the most efficient form possible. And it's your job to recognize that and work with that and make it usable in your system that you're building. All right. So that was a lot. We will pause for questions, but before we do that, we have 3 possible sort of exercises we can do today. One is just generating some keys and looking at the formats of those keys and kind of converting them from one format to another. The second is to actually just take so that's the keys is the first one. The second one is to take some data and convert it, like between, base 58, we'll play with that, and we'll play with hex too. So that's conversion is the second one. The third exercise we could do is actually go get a little reg test node set up, and go look at, print out onto the screen some transaction data and kind of look at what data formats are being used there when we're actually looking at blockchain data. So those are the 3 options: playing with the keys, actually converting data to different formats, or going and looking at that data in the blockchain. So you all please drop in the chat and tell me which one of those exercises you'd prefer to walk through today. And also, Mike, I'll ask now if we have any further questions.
All right, yeah, well, we'll give everyone a little bit of time here. So I was giving people, we already have 2 votes, it looks like, for option 3 for the exercise.
Okay.
But we'll give people a little bit more time here. I should have lined up some maybe some Jeopardy, some royalty-free Jeopardy music, some sound alike, I believe is the term.
All right, excellent. So I'll just remind people of 3 options. We can play with key formats, we can convert some data just via Python, or we can go look at blockchain data via just like a little reg test node. So those are the 3 options. And maybe I'll just talk through the different Bitcoin networks here briefly, because we'll need this for next week anyhow while people vote. And after I do this, we'll tally the votes.
Sounds like a good plan.
Cool. So blockchain data, something to keep in mind are the different Bitcoin networks, right? So we've mentioned testnet on a number of occasions. I'm a huge fan of testnet. Please use testnet. Just, being I like, proper structured development. Please don't ever experiment or develop on mainnet. Please always use testnet while in development. See a lot of people, especially with the Lightning Network, that's on the topic. People use mainnet. I'm like, oh, please don't do that. So let's walk through this. Mainnet is the real Bitcoin, the Bitcoin that actually has value. It's what we're referring to every time we've been talking here and saying Bitcoin and the Bitcoin network and Bitcoin, the units, that's what we mean. But there's a whole nether, there we go, use testnet, please. There's a whole nether Bitcoin network, which is a separate Bitcoin network with a separate blockchain running the same software, but it's testnet. And it's specifically made so that it does not have any real monetary value. You cannot, anywhere you go, except maybe at like a developer conference somewhere, The testnet coins are not going to have any value. You can't ever buy a cup of coffee with it unless you're sitting next to someone who's working on applications like, oh, I need more testnet coins to test my app. There, maybe it might have a tiny bit of value, but otherwise it does not have any monetary value. It is purely for testing, right? So if something goes wrong and coins get burned or lost, it's not a disaster, right? So please use the testnet. There's also another one called reg test or reg test, people say sometimes. And this is where you create your own local blockchain network, right? Your own Bitcoin network. So it's just for on your machine. You can also, some people use Docker containers to spin up 5 different nodes using reg test, all the same network on their computer. And it's what all of these things have in common is they're all running the same software. It's just about which computers are on the network. So as you're developing, I highly recommend start with reg tests, right? Then graduate to testnet, then only once you're actually production ready, you've gone through all the tests, then move on to mainnet. So with that said, Mike, let's tally the votes. What exercise should we do?
Well, it looks like the winner is still option 3. We had someone say option 2, but option 3 still has it, unless there's a bunch of last-second votes coming in. But if polls are closed.
If polls are closed, we'll officially close the polls. Okay. All right. So option 3, we'll also declare the winner. All right. So what I'm going to do here is we're going to go to this website because they have a nice little sandbox, right? So we're going to spin up a reg test node and we will walk through it. So I'm also going to, can I copy this tab? Hold on. I think I can. Okay, hold on just a second. I know what I'm going to do. All right, excellent. Okay. I just want to have this on another screen here so I can follow along with what we're doing. All right, so let's close this, go here. Okay, and I've got it all turned on. All right, so we got you. Excellent. We are booting up a Bitcoin node. And again, this is running on its own separate network, right? It's really only talking to itself. Not at all useful for actual Bitcoin applications, but incredibly useful for what we're going to do here is just walk through, get familiar with some of these commands, and walk through looking at some actual blockchain data, how the Bitcoin software stores this data and presents it to us via the command line. All right, so I'm going to kind of breeze through these commands, just talking about them briefly as we go, because next week we're really going to go, we're going to set up a node properly and really going to go in depth with what's happening here. All right. So when we interact with Bitcoin on the command line, we use this Bitcoin-CLI, right? So I'm just going to do get info. You can see I have a node running here. We got some version data. Oh, look at that. We have 0 blocks, right? Because our own private network, we're not getting blocks from anywhere else. All right, so I'm also going to take text. Let's see if I have text editor. There we go. Boom. Okay, put this over here because I'm doing some copy paste. Let's see, where did my text go? Okay, awesome. Cool. Okay, so I'm going to generate a new address. I'm going to type this here. No, why is my phone ringing? There we go. Off that goes. Okay. Here we are. This is Bitcoin address. Notes that it starts with 2. That's interesting. Okay. Now I'm going to do get block count. Right. So how many blocks do we currently have in our blockchain? We have 0. Unsurprising, because we haven't made any because we're the only people on this network, right? It's just me. So to make some blockchain data, we are going to tell this reg test node that it's got to generate some transactions here. So we're basically going to mine some blocks, right? Remember, we talked about mining. Right now, the difficulty level on this mining is at very, very low. So this little, app running in this browser or on someone else's server can easily mine some Bitcoin here for us. So we are going to create, I think this, yeah, generate to address, this mines 10 blocks and sends us all the block reward, right? Oops, we got to hit enter. Boom, there we go. I believe these are the blocks we had just mined. I'm gonna grab, I think that's what this is. Let's get this out here. Let's copy this. Okay, just holding on to that. Okay, now we'll go on to the next one. All right, now let's do again this. Get block count. Boom, we have 10 blocks, but let's do get info. Our balance is still 0. Now, I'm not sure we discussed it, but certainly but certainly we discussed it in the course that the block reward isn't spendable until another 100 blocks. Won't dive into why that is, but basically we can't use this Bitcoin until it's 100 blocks deep into the blockchain. So let's generate 101 blocks. Boom, that's a lot of blocks. Okay, cool. Now we'll go back and generate get block count. Look how many blocks we got. Excellent. Now we can actually start looking at some of this data, which is what we wanted to do. So we copied one of these block hashes. I think that's what I got here. So hold on just a sec. Okay, copy all of this off my clipboard over here. All right, so I want to tell Bitcoin now to pull up this particular block. But first, before we do that, let's have a look at this data here. And let's again have someone try and tell me what format we're looking at here when we look at this data. So let's see, we have the number 4, we have a lowercase a, we have the numbers 6, 7, 1, we have B, C, D, F. Okay, so we've got a lot of letters from the alphabet. Do we see any letters we see all one case though, like these look like all lowercase letters. Do we see any letters from the end of the alphabet or maybe just A through F, right? What do we got here? So Mike, do we have any guesses as to what format we're looking at here?
We're working on it here. I'm trying to get him a bigger view. David Cooper has guessed the hex. Also has explaining Bitcoin guessed hex. Oh, David, awesome. Everyone's guessing hex.
All right, then everyone is correct. Nice work, y'all. Okay, cool. So there we go. Actually, let me see if I can do this. Hold on, Mike. This might solve our problems. Does that help or does that make it worse?
Give me 1 second. I'll tell you. I think chat can tell me whether it makes it better or worse. Now, I think it's smaller than I had it for them before in this view, but I'm not entirely sure.
Okay, then we won't do that, and then maybe we can just zoom.
Because I'm already zoomed in on you, so don't yeah.
Oh, okay.
Yeah, go back to where you were if you were going to zoom, because I zoomed for us.
Okay, excellent. So I won't mess with it.
All right,
we've done it. Okay, cool. All right, now let's look through what data we have here. So we said, hey, please get this block. All right, so here's the hash of the block displayed in hex. We have lots of interesting information about it, blah, blah, blah. Here's how many confirmations it has. Here's the size, weight, that's another topic. Merkle root, hey, we've gone over that. And here we have transactions. Here is a transaction ID, right? This is what we want. Let's take a look at that. All right, now let's also look at that transaction ID and say, what sort of format is that? Well, this also looks to be hex as well. Okay, cool. So we can see what Bitcoin's doing there. Now let's go and dig into that specific transaction. So let's look here. I'm going to use this Bitcoin CLI command called get transaction. Let me just copy and paste this. All right, there we are, Bitcoin CLI, please get this transaction. Boom, cool. All right, so now it makes this kind of human readable for us. Look at that amount, 50 Bitcoins, woohoo, I'm reg test rich, right? All right, so we've got some confirmations. This is the hash of the block it was included in. Here's the transaction ID. And so what Bitcoin does here, Bitcoin CLI, is it makes a lot of this human readable for us, right? And, here it's laying out here's the timestamp on it, giving us all kinds of details. Here's the address that was used. Here's the amount. Again, we talked about, inputs and outputs. We can see that. But then here's the transaction, the whole thing bottled up in hex, right? Just some raw hex. So what may happen is that when you're working with data, like if you're actually trying to see what's going on in the blockchain, you're building some sort of application, you may run across a situation where you're getting transaction data and it's being delivered to you like this, just in hex, right? And then you're gonna have to look at that, like this is a transaction, oh crap, what is that? Oh, that looks like hexadecimal, right? So now thankfully, in the Bitcoin software, right, you can, pull out you can use the Bitcoin software to then translate this into something that you can much more easily pull out the data. But it's going to be your job to look at that. You might just be handed this information and it's your job to then deal with it appropriately and pull out, perhaps you want the amount. Perhaps you need the exact input used in this transaction, whatever the case may be, whatever application you're working with, you might get handed this data and then have to work with that appropriately. Okay, so I think that's where we're going to stop there for this particular exercise. And it looks like pretty good timing because we only have about 5 minutes left. So let's just switch back to our question slide. There we go. And Mike, do we have any questions about this?
I'm not seeing questions just yet, but we'll give everyone a second. I did see a question about posting the sandbox link. I'll add that to the description of this video after we're done here. Because
Okay.
I tried to share it, and I think I shared the wrong one. So I'll share that out. Come back a little bit later today, and I'll add that to the description of this video.
Cool. I also believe there may be more than one of these. Like this is just one that I found that does a nice job. So I'm not particularly familiar with this website or what they do, but thank you for the sandbox. So if you Google or search for, Bitcoin reg test sandbox, you could probably find some other ones as well. But this one has worked well for me in the past. So shout out to them. Thank you.
All right, awesome. And let me just, while we wait here to see if any more questions, I'll just pass the shout out back to you. Thank you for taking us through this. Again, we'll be back here again next week doing the next unit. And of course, if this is your first time joining us, there's a playlist with the links to all the other videos we've done prior to this. And of course, these videos are a supplement to Saylor Academy's course. So of course, go up there, start taking the course, catch up with us. Yeah, but I'm not seeing any questions coming in. So again, just want to thank you, Hannah, and thank everyone for joining us while we just wait and see if any last questions come in here.
All right, cool.
All right.
Well, I think I will see you all next week then.
All right, excellent. Thank you all so much for joining us, and we'll see you the same time next week.